Hi students, this is a video on solving systems by addition. Now when I say systems, I mean linear systems of equations in two variables. Okay, on my previous video I talked about solving by substitution, which is where you substitute an expression for one of the variables in the other equation. Addition, or the addition method, is another way of solving a system of equations. But again, once again, when I say systems, I mean linear systems. So linear systems of equations in two variables. Okay? So in two variables, x comma y. So just like my earlier video on solving by substitution, our answer is going to be in the form x comma y, assuming that an answer exists. Okay, so let's jump into an example here. Now, with the addition method, it can be very handy on certain types of systems. And this first system that we're going to see here in this example, they're going to ask us to solve by the addition method. Solve by the addition method. Okay. So, what is the addition method? Well, probably the easiest way to learn it is just by example. But I will write the steps as well. Okay, so example number 1, we want to solve the system. And here our first equation is 2x minus y equals 6. And our second equation is 5x plus y equals 22. So as we work through this example, I'm going to go ahead and write the steps. So the first step that you want to do when you're solving by the addition method is you want to line up the variables and the constants, and then you want to multiply one or both equations by a constant so that when you add the equations, something is going to cancel out. A variable has to cancel out. Okay, so step 1 is actually line up the variables. Now, as you can see in this one, for this particular example, the variables are already lined up because we have the x's first, then we have the y's, and then we have the constants on the other side. So you also have to have the constants on the other side. So this is the standard way to write it. Okay, so step 1 is line up variables, multiply one or both equations by a constant. Okay, multiply one or both equations by a constant. And that's only if needed. Okay? And it's only needed if when you add the equations, nothing is going to cancel out. So of course it's called the addition method because what we're going to be doing right after this is we're going to be adding the equations. Okay, but with this particular problem here, if I just add them the way they're written, I notice that I have a negative y in the first equation and a positive y in the second equation. So I can just add these the way they're written and the y's are going to cancel out. Okay, so you line up the variables, multiply one or both equations by a constant if needed. That was not needed here. Okay, then add the equations. And when you do that, if you've done it right, one of the variables should cancel. Okay, so like here, we can see that if we add them, the y's are going to cancel. So I didn't need to multiply by a constant. Okay, there was no need because I see the y's are going to go away. All right, so how do you add them? Well, as long as everything's lined up like this, which this one is, you just go ahead and add straight down. Okay, so adding straight down, we have 2x plus 5x is 7x. Okay, so when we add them like that, we're going to get, let me write it down here, 2x plus 5x is 7x. Okay, and then negative y plus y is 0. Okay, so we have 7x plus 0 equals, and then on the other side, we have 6 plus 22, which is 28. So 7x plus 0 equals 28. All right, and of course, you don't have to write plus 0, because any number plus 0 is the number. So we just erase that, and we just get 7x equals 28. Okay, and then what you want to do with this one is you want to solve this equation and then plug back in to one of the original equations. So that's our second step. Okay, so solve the resulting equation. Solve the resulting equation. And plug in. Okay, and you need to plug in to one of the original equations. And it doesn't matter which one. So you can choose whichever equation looks a little bit easier. Okay, it just has to be one of the original equations. But again, it doesn't matter which one you pick. So just pick the one that's simpler to solve. Okay, so to solve this equation, 7x equals 28, what we need to do is to get rid of the 7, we're going to have to divide both sides by 7. Okay, so we divide both sides by 7. Okay, and that's going to give us, on the left side, we just have x, and then on the right side, 28 divided by 7 is 4. Okay, so we actually get x equals 4. And I'm going to go ahead and underline that. But remember, when you're solving a system of equations in two variables, there's two variables, x and y. So just because you find one variable doesn't mean you're done. Now that we've found x, we still need to find y. Okay, so to find y, we need to plug into one of the original equations. Now we can either do the first one or the second one. Now me personally, I would do the second one, and the reason is, the second one doesn't have anything multiplied times y. So this one's going to be easier to solve for. So I'm going to go ahead and plug in into this first equation. I'm sorry, not first equation. I misspoke. The second equation. Okay, so we're plugging in x equals 4 right here into the second equation. Okay, so we're going to get 5 times 4 plus y equals 22. Okay, so 5 times 4 plus y equals 22. So all I'm doing there in that step is I'm plugging in x equals 4 into the bottom equation. I chose the bottom equation because it looked easier to solve, because y is easier to solve for here. So I got 5 times 4 plus y equals 22. Okay, and then of course you have to solve this equation, and then you're done. Okay, so step 3 is solve this equation. Okay, so the new equation that we got here. So then what do we get? Well, 5 times 4 is 20. So we have 20 plus y equals 22. And then to finish isolating y, we're going to need to get rid of the 20 on the left side. So we're actually going to minus 20 from both sides. Okay, and what's that going to give us? Well, on the left side, we're just going to have y, which is what we want. And then on the right side, we have 22 minus 20 is 2. So we actually get y equals 2. Okay? So So now we actually have both x and y. So we know that x is 4. We got that in step 2. And then y equals 2. We got that in step 3. So how do you write your answer? Well, hopefully you already watched my video on solving systems by substitution. So the way you write your answer is x comma y. Okay, so for your official answer, it's going to be of the form x comma y. So here that's going to be 4 comma 2. So that's in the form x comma y. Here x is 4, y is 2. Okay, so I'll go ahead and box that. Alright, so that completes our first example. Now these do take a while, so I'm not going to be able to do every type of problem, but I'm going to try to do a harder problem now. Since that one was pretty easy because you just add them and the y's canceled. Your second homework problem is also pretty easy. The x's are going to cancel, so we're going to skip that one. Your third one is also pretty easy, but it probably would be good to do it because it is a little bit harder. Okay, so for our second example, we're going to be solving by the addition method. Okay, and for this one we have 3x plus y equals negative 3. And then the second equation is 5x minus 3y equals negative 89. Okay, so 3x plus y equals negative 3, and 5x minus 3y equals negative 89. Okay, so the reason I'm doing this one is it's a little bit harder than the last one, because remember the first step. What did I say the first step was? Let's go back up here. In the first step I said you line up the variables and then you multiply one or both equations by a constant if needed, then you add the equations. And what needs to happen is a variable has to cancel out. So when I say if needed, I mean so that a variable cancels out, or in other words, is eliminated. Okay, so a variable is eliminated. Now the first problem was so easy, we didn't have to do this part. So we just added them and the y was eliminated. Okay. And by the way, some other books call this elimination method. That's what people used to call it in the old days, because you eliminate a variable first and then you solve and then you work with that. But now it's called the addition method because you're really adding the equations. But those actually mean the same thing. Okay, so for this one that we're working on here, the problem here is that if I just add straight down, the x's are not going to cancel because 3 plus 5 is 8, and then the y's are also not going to cancel. So we can't eliminate a variable the way it's written. So what we have to do is we have to multiply one or both equations by a constant as needed. Now what is needed here is either y has to cancel or x has to cancel. Now it would be harder to get rid of x, and the reason is here we would have to multiply this one by 5, and then we'd have to multiply the bottom one by 3. That's going to be a lot bigger numbers. Then if we try to get rid of y, we notice that the bottom one is already negative 3y. So if we make the top one positive 3y, then positive 3y minus 3y is 0. Okay? So what that means is we need to multiply the top equation by 3. So that's what we're going to do. So we're going to multiply the top equation. Now you have to do it on both sides because it's an equation. Multiply both sides of the top equation by 3. Okay, and then this whole thing is transformed. So now the top equation is going to be, if we distribute the 3 on the top, we get 3 times 3x is 9x. and then 3 times y is 3y. So we get 9x plus 3y equals, on the other side, we have negative 3 times 3 is negative 9. So we have 9x plus 3y equals negative 9 for the top equation, but the bottom equation is still the same. So the bottom equation is still 5x minus 3y equals negative 89. Okay, and if the problem were harder, we might have actually had to multiply both equations by a constant so that when we add them like this, something's going to cancel. But I chose to get rid of y on this one because it looked easier. To get rid of x, you would have to multiply the top equation by 5 and the bottom equation by negative 3. And then you would have 15x and negative 15x. So it's sort of like you have to multiply by whatever's missing. So like if you look at the y's here we have a negative 3, there we just have a 1. So we had to multiply the top one by 3. Okay, and they also have to be opposites, which means they're opposite signs. So here, notice that the top one is positive 3y and the bottom one is negative 3y. Okay, so what we have to do now is, now we can see that the y's are going to cancel, so we can go ahead and just add straight down, because everything's all lined up. So this is another problem where it was already lined up, so we didn't have to do that. Okay, so adding straight down, we get 9x plus 5x is actually going to be 14x. Okay, so we have 14x, and then the y's just cancel out. In other words, we eliminate the variable y. Okay, so y is eliminated. So we have 14x equals negative 9 minus 89. If you can't do that in your head, you can just do it on a calculator, but they are the same sign, so you're going to keep the sign and add. Okay, and then 9 plus 89 is going to give us 98, but we keep the sign, so it's going to be negative 98. Okay, so we have negative 98 there. All right, and then to isolate x here, we have to solve this equation. So to solve this equation, we have to divide both sides by 14. So we get x equals negative 98 divided by 14. Now, unfortunately, those are some bigger numbers than what we're used to. So you can use a calculator here if you don't want to deal with dividing by hand. Any calculator is fine. If you just use the one on the computer, that's fine. So we have 98 divided by 14 gives us 7. Okay? But here it's going to be negative 7 because it was actually negative 98. Okay, so we get x equals negative 7. All right? So I'll go ahead and underline that one. So we found the first variable. Now we need to find the other variable. And how do we do that? Well, we plug in x equals negative 7 into one of the original equations and then solve. So looking at the two original equations up here, we can see that the top one looks like it has smaller numbers, so that's probably going to be the easier one. So I'm going to plug into the top equation. So I'm going to replace this x here with negative 7. That's what we got for x. So we're going to have 3 times negative 7 plus y equals negative 3. Okay, so 3 times negative 7, just plugging in x to the top equation, plus y equals, what was it? I already forgot. Negative 3. Negative 3. And notice we're plugging into the original equation before we multiplied both sides by 3, just because it's easier. The smaller the numbers are, the easier the problem is. Okay, so we got 3 times negative 7 plus y equals negative 3. Okay, and then we want to solve this equation for y. So on the left side, 3 times negative 7 is negative 21. So we have negative 21 plus y equals negative 3. And then to finish solving for y, we need to get rid of the negative 21. So how do we do that? We go ahead and add 21 to both sides. Okay, so we're going to get y equals negative 3 plus 21, which is actually going to be the same as 21 minus 3, which is 18. So we get y equals 18. And by the way, you can check these if you want to plug in x and y together in the original equations. You're allowed to do that. It can be a bit of work, but if you plug it into the two original equations, you should make sure that the equals is true. So you plug them in, you simplify it, and then you make sure that each equation is true. But I usually skip that because it's a lot of extra work. And many times it's easier to just check through your work than to actually plug everything in to the original equations to check. So I'm not going to bother to check. Okay, so we got x equals negative 7, y equals 18. And then once again we write our answer in the form x comma y. Okay, so here our answer is going to be negative 7 was x, comma 18 was y. Okay, so negative 7, comma 18. All right. So I did want to do a little bit harder question. A lot of your homework problems from this section are pretty straightforward. So I wanted to jump ahead to one that wasn't as straightforward. Although it's not incredibly difficult, it isn't quite as easy. So hopefully you already watched my other video because I talk about the different cases for solving linear systems in two variables. So I said there's actually three cases. The first one is one solution, which is what we've been getting here. Remember, these are a point x comma y, and a point x comma y is 1 point, so that's considered one solution. But there were two other cases. There was a case where we had no solution, and then there was a case where we had infinitely many solutions. So I wanted to make sure that I cover those again for addition. Okay, for my last two examples. Okay, so our example number 3 is next. So what's our example number 3? Example number 3 is going to be 2x plus 4y equals 0, and then 4x plus 8y equals 1. Okay, 2x plus 4y equals 0, and 4x plus 8y equals 1. Now the reason I say this one is a little bit harder is you might not be sure what to multiply each equation by so that stuff will cancel out or a variable will be eliminated. But I would focus on whichever variable has smaller numbers. So here I'm going to focus on the 2x and the 4x. So how am I going to get 2x and 4x to cancel? Well, basically you multiply the equations by whatever you're missing. Now what do I mean by what you're missing? Well, on the bottom we have 4, on the top we have 2. So what are we missing on the top? Well, we know that 2 times 2 is 4. So we're going to want to multiply the top equation by 2. Because we'll know that then we'll have 2 times 2 is 4x, and then the 4x and the 4x should cancel. However, you also have to multiply by a negative. So why do I need to multiply the top equation by a negative? Well, remember, you're going to be adding these equations. So one equation has to have the opposite sign of the other equation for that variable. Otherwise, the variables won't cancel, so they won't be eliminated. So instead of multiplying the top equation by positive 2, I'm going to multiply the top equation by negative 2. So negative 2 is going to make it so that the x's are going to cancel out. But of course, you have to distribute the negative 2 on the left side of the top equation. So we're going to get negative 2 times 2x is negative 4x. And then negative 2 times 4y is actually negative 8y. So we have negative 4x minus 8y equals, well, on the other side, 0 times negative 2 is 0. Okay, so our new system now is going to be negative 4x minus 8y equals 0, and then the bottom equation is still the same, so the bottom one is still 4x plus 8y equals 1. Alright, now that first step was a little bit trickier because we ended up having to multiply by a negative. But other than that, we should be good. So what do we do next? Well, now we're ready to go ahead and add the equations because we can see we have negative 4x on the top and positive 4x on the bottom, so they're going to cancel out. So if we add the equations, the variables are already lined up, so we just add straight down. So adding straight down here, we get negative 4x plus 4x is 0, but then we have an interesting situation. Negative 8y plus 8y is also 0. So on the left side, we actually just have 0, because all this stuff got eliminated, not just x, but also y. But on the right side, we have 0 plus 1, which is 1. So we're left with the equation 0 equals 1. Obviously, this is not true. This is nonsense. And in fact, that is never true. This is never true. So if you watch my other video on solving systems by substitution, you'll know that when it's never true, you get an equation that's called a contradiction. Okay? And that means that there's no solution. Okay, so our answer is just going to be no solution. Or on my math lab, they say there is no solution, and then they write the empty set. Okay, so they say there is no solution. And then they, for the solution, since there isn't one, they write the empty set. So they write curly braces with nothing between them, which the empty set is sort of like a box with nothing inside of it. Or you can write it as sort of looks like the no smoking symbol without a cigarette in the middle. So it's a circle with a line through it, and that's also the empty set. That just means that it's never true, so there's no solution. Okay, so that's how you're gonna write your answer on My Math Lab, except it's already written, so it's more of a button that you're gonna click when you're doing your homework. Okay? So hopefully that is good. Basically the same idea as what we did on the last video. Okay, and I wanted to do one more example. So this is going to be example number 4. Okay, so for example number 4, we have a system of equations. The top equation is negative 3x plus y equals negative 1. And the bottom equation is 9x minus 3y equals 3. Okay, so for this one, once again, if we just add straight down, the variables are lined up, but if we add straight down, the x's aren't going to cancel and the y's aren't going to cancel. So that means we have to do in our first step, we're going to have to multiply one or both equations by a constant so that a variable is eliminated when we add. So in particular, if I notice on the bottom equation, I notice I have a negative 3y, whereas in the top equation I just have a y. So if I decide to get rid of the y's here, what I can do is I can multiply the top equation by 3, so that I'll have a positive 3y and then a negative 3y, which will cancel. Okay, so that's going to be our first step. So our first step is going to be to multiply the top equation by positive 3. Now, why is it positive 3 this time, and last time it was a negative number? Well, here, the bottom equation already has a negative 3y, so we want the top equation to be a positive 3y, so they'll cancel. So that's why we're doing a positive 3. Okay, so multiplying that on the top equation, we're going to get a new system. So the top equation is now going to be, if we distribute the 3, we get 3 times negative 3x is negative 9x. 3 times y is 3y. And then on the other side, negative 1 times 3 is negative 3. And then on the bottom equation is still 9x minus 3y equals positive 3. All right, so now we can see that the y's are going to cancel, so we're just going to go ahead and add straight down. But we can already see that these equations are basically the same thing, but every term is an opposite. So this is another weird case. So we can see that negative 9x plus 9x is 0, so these cancel out. 3y minus 3y is also 0, so those cancel out. So on the left side we just have 0. And then on the right side, strangely enough, negative 3 plus 3 is also 0. So on the right side we also have 0. So we have 0 equals 0. Well, not only is this true, but this is always true. Right? This is always true because 0 is always equal to itself. On the last problem, we got 0 equals 1. Well, 0 equals 1 is never true. So if you get something that's never true, like one number equals a different number, that's always going to be no solution. Whereas for this one, if you get a number equals itself, something like 0 equals 0, or 2 equals 2, 1 equals 1, that kind of thing, this is always true. So this is actually the reverse of the last problem. Even though it looks kind of similar, this is always true. Now, if something is always true, not only does that mean it's going to have a solution, it's actually going to have an infinite number of solutions. Okay, because with a linear system like this, to always be true, that means each line has to be on top of each other, so they have to actually be the same line. Okay? But if you want more details about this, you should watch my earlier video on solving systems by substitution, because I talk about that in a lot more details. But anyway, if it's always true, what we write is infinitely many solutions. Okay, infinitely many solutions. Right, and that's actually what they write on my math lab as well. Okay, but the only thing that's a little strange is you also write the set builder notation. So the set builder notation, again, watch my other video for details, but you write a curly brace and then you write x comma y. So that's the set of all x comma y, and then you write a vertical line, which means such that, and then you write, you're going to write one of the original equations. So in the original equations, we had negative 3x plus y equals negative 1. So I'm going to write that here. Okay, so negative 3x plus y equals negative 1 was one of our original equations. And if you want to know more why this is true, you need to watch my other video, because I'm not going to explain the same stuff all over again. And then the other equation, the other set builder notation is going to be the set of all x comma y such that the other equation is true. And remember, in this problem, our other equation was 9x minus 3y equals 3. 9x minus 3y equals 3. And all this is really saying is, basically, since we got an equation that's always true, that means that these two linear equations represent the same line, so the lines are right on top of each other. And if two lines are right on top of each other, they have an infinite number of points of intersection. And each point of intersection is a solution. Okay, so you have an infinite number of solutions, so that's why it's the set of all points, x comma y, such that each of these equations is true. Okay. But fortunately on my math lab they make it a lot easier, because this is literally just a button that you click. So you just click the button that says this whole mess here. Okay? And that completes this video. Thanks for watching.